So now we'll proceed further with the methods. Okay, with methods. Now we know we have learned one method, which is basically constructor, right? So what is the constructor?
Whenever
Okay,
object is created, this method will be called.
right. So it is a special method which gets called whenever an object is created, which gets called by default whenever a object is created. Yes. Now we can, since it gets called whenever an object is created by default, we can use this special method, which is called underscore underscore init underscore underscore to construct our object, right? We can parameterize this special method and pass all the required values, and we can use those passed parameter values to build our object, to build our object. Now the first parameter of the constructor is always self. Now what is self? Self is nothing but the object itself. Self is nothing but the object itself. Yes.
Yes, sir.
Yes, sir.
Yeah. Now use, since the first parameter is self, which is nothing but the object, we can use self as a reference to create variables at a object level, to create instance variables. All right. Now we have already seen one method, which is init. Now we will see more methods. So there are, when it comes to methods, right? So there are instance methods. There are class methods. There are static methods. There are three kinds of methods: instance methods, class methods, and static methods. Now, what is the difference between each of it? OK, so all these methods should be defined within the class itself. All these methods should be defined within the class itself first, right? Instance method, for class method, we use a decorator called @class method on top of the method. OK, on top of the method. Example, class method. On top of it, we'll just say @ class method. Now, when I say @class method and I create a function under it and I create a method under it, it becomes a class method, and the first parameter would be class. And the first parameter would be CLS, which is nothing but class. OK, an instance method is again created in class without any decorator. OK, and first parameter is
Self.
self. First parameter is self. Here first parameter is
Class.
CLS, which is nothing but class. Here self means what?
Object.
Instance or object. Here
Instance.
class means class name. Class name, right? From instance method, right? We can access both class and instance variables, whereas from class method, we can access only class variables. We can access only class variables. Now, what is static method? Created within the class with the decorator at the rate static method. At the rate static method. And doesn't have any default parameters. Doesn't have any default parameters. So here for instance method, the default parameter is self. For class method, the default parameter is CLS. And for static method, there won't be any default parameters. There won't be any default parameters. Right? Static method. Right. So now there are three kinds of methods: instance method, class methods, static methods. Instance method created within the class without any decorator, and the first parameter is always self. Self is nothing but instance. From instance method, we can access both class and instance variables. Class and instance variables. Clear?
Clear, sir.
Yes, sir.
Right? We
Yes, sir.
use, and for the class method, it is created within the class, and also we use a decorator called at the rate class method. At the rate class method. And we use the decorator at the rate class method, and the first parameter is CLS. The first parameter is CLS. From class method, we can only access class variables, but not instance variables. Okay, but not instance variables. But whereas for the static methods created within the class with the decorator at the rate static method, with the decorator at the rate static method, and doesn't have any default parameters, it doesn't have any default parameters. Right? Am I clear? So for this, no, it cannot access instance or class variables. It cannot access instance or class, cannot access instance or class variables. Clear?
Clear, sir.
Yes, sir.
Clear, sir.
Okay. Now let us see each one of them. Right. So let me do one thing. Let me create one student class. Cool. This branch. What do you call branch only, right? In inter is whatever it is by PC, MPC, it is called branch only, right? So the scroll branch. Call it as this branch register number. These three details I'll take, and student I'll say first name, last name. Okay, all right. Right now, I want to get a full name of the student. I want to get a full name of a student. So let me just create a student object. S1 is equal to student, and we know it takes 4 parameters. First name, branch is going to be MPC, and register number I'm going to say 123. Right now, print S1, it creates it as an object. And if I want to know what is there in that object, I can say dict of S1. Okay, I'm just converting that object to a dictionary. Let us see what it will do. So that way you can see what is there in that object. Sorry. And instead of that, they will call another special property. Right, underscore underscore DICT underscore underscore. This is a special property which converts that object into, right, a dictionary. These are all the instance variables. Yes or no?
Yes, sir.
Right, first name
Yes,
Raghu,
sir.
last name
Yes.
Ram, branch MPC, register number 123, and so on. Now what my objective is to build the full name. So which is, it will become like, Raghu plus Ram will be Raghu Ram. Now what we want to do here, what I can do is print S1 dot first name plus, then I'll add some space, then plus I'll do S1 dot last name. So this will give me the first and this will give me the full name, right? Because I know my object is S1 and I'm using that first name and then last name, right? And if I create multiple objects, forgive me for the spelling mistakes if there is anything. All right, right. All right. Right. So some first name, last name. Right. Something like this. Right. Now I have created a 3 objects. So let me just say S1, S2, S3. Let me rename this S2, S3. Now, if I want to need a full name of 3 different objects, so what I have to do? S2, S3. Right, this way I can create the full name of 3 different objects. right? But here I'm doing whatever I'm doing here. Rather, I would create one instance method. Rather, I would create one instance method def full name, and the default first parameter is self, right? And I'm not going to do anything, so I'm just going to return, right? Self dot, or I'll just say f of self dot first name, then self dot last name, right? Done. Right. So what it is going to do, instead of this, what I'm going to do is s1 dot full name, s2 dot full name, s3 dot full name. So what we have achieved, okay, I have to, since it is returning, I have to print that. It is not, that function is not printing, but rather returning, and hence we are going to print that returned value. Okay. Right. This also gives the same output.
Yes, sir.
Right.
Yes,
Now
sir.
this is the instance method where the first parameter is self. Self is nothing but the object. Instead of using s1 here, it uses self. Instead of using s2, it uses self. Right now, right. So did we understand so far?
Yes, sir.
Yes, sir.
Okay.
Yes,
Now,
sir.
right. So now self dot by default, all the students are a part of the school. Now the student leaves the school. The student leaves a school, and hence I want the active status to be changed to false. Great. Here, now what I'll just say is self dot active is equal to false. Def join school. Self dot active is equal to true. Right. So if I leave school, I want to make the status as active, which is false. If they join school, I want to say make this active status as true. And def get status, and I'm going to return active. Now what we'll do, get active status. OK, it gives that active status is true. Now what I'm going to do, self dot what happened. So this is a leave school only, right? Not self, sorry. This one dot leave school, I'm saying. Right. And after leave school, what should the active status be?
False.
Right. Let us see for this if did that worked. So first it was true, and after leave school, it became false. Now what I'm going to do is, again, I'm going to say join school, and right. So again, it became true. Now, what are we trying to solve here is that with the instance method, we can access and modify the instance variables. We can access and modify the instance variables. Are we clear?
Yes, sir.
Okay.
Yes,
Now
sir.
there
Clear, sir.
might be case that I want to modify the class variables. Okay. Now, whenever I want to modify the class variables, I have to use the class methods. For class methods, what did I say? At the rate, class method is the decorator that we have to use. Def, right? Or we'll just say set name. And if you see, right, what is the first parameter here? Now, instead of self, it says CLS. CLS nothing but class.
Class name.
Okay. Right. I'm going to just say what is the name that we are going to pass. But here, instead of that, what I'm going to do is I'm just going to say CLS. I want to see what is CLS. Right. So yeah, we'll call this function now. What is it? Print, not print, self dot. I can use it with the self. OK, and not self, sorry. S1 dot set school name. And let us see what it prints. We are printing CLS. Let us see what is CLS. Hold on a second. OK, we have to pass one parameter, no? Because it takes one parameter, name, and let's pass that parameter. Let us run this again. Right, what does it say? Class main student. And I also will print, OK, and I also will print student. Now, are these both same? CLS is nothing but the class name, class reference itself. CLS is nothing but the class reference itself. Are we clear?
Yes, sir.
Yes, sir.
Yes, sir.
OK. Now, whenever I want to modify any of the class level variables, I have to use a class method. Whenever I want to update class level variables, I have to use class variable, class method. So what I'll say CLS dot school is equal to name at the rate class method def set branch CLS dot school branch is equal to whatever is the branch that is passed. Okay, now here after setting the school, right? What we are going to do is S1 dot. Let us see if that variable has changed. Okay, let us run and see. And before this also I'll print what is school, and after that also we will see what is that. So earlier the school name was Chaitanya, and later after setting the school name is Sri Chaitanya. It is the way we are accessing is same, right?
Yes, sir.
Before
Sir.
setting it was one value. After
Yes,
setting it got
yes,
the
sir.
updated value. Right. So we'll see before setting and after setting. So if you see here, before setting it was Anantapur and later it got changed to Raptadu, right? So if at all, if you want to change, if at all, if you want to change, right, it doesn't matter now, it has changed. Whether I access it with the object or with the class name, right, with the object or with the class name, they both should reflect the same value, which is what is happening here. Okay, now if at all, whenever you think you want to modify or update the class level variables, you have to use class method. Okay. And whenever you want to update instance levels variables, you have to use instance method. Are we clear?
Clear, sir.
Clear,
Okay.
sir.
Clear, sir.
All right. Now, when do we want to use a static method? Now, what I'm going to do here is right, by default, there is no score here, right? Now, what we are going to do for student, I want to update the score. For student, I want to update the score. Right, what I'll do, right? So the score, I want to basically take one function where pass in several parameters and that or maybe average. What is average or percentage? Right, percentage. So by default, I'll say none. So I have not assigned anything to it. Right, it's not zero nor any value, but it says none. None means it doesn't have anything. Now I will have one static function because static function should not technically care what is def at the rate static method at the rate static method def takes two parameters. What is the total? How many subjects? How do I get the average? How do you calculate the average? Right. So this is simple. Now see this function, right? This function calculate percentage because the percentage is supposed to be calculated per student. So it belongs in this class and it belongs in this class, but it should not contain access to the class or a instance variables. But whatever we want to do, we have to pass the parameters and get the desired output. So that is where we use a static method where this method should not have access to instance variables. This method should not have access to class variables. If it doesn't want access to both class and instance variables, but still that function belongs to this class, then you have to use static method. You have to use static method where from this method, it cannot access any of the instance or a class variables. It cannot access because there is no self to access class variables. There is no CLS to pass to access the class variables, right? Because it is a static method, it will not have access to class or instance variables. Are we clear?
Sir.
Now what we are going to do here, now s1 dot, right? Compute percentage 300 is my total and I have 6 subjects, right? This gives a percentage. This gives a percent. Or right, I'll write one more instance method. right? Subjects, let us say it is always going to be 6. I'm making it as a class variable because this should not change, right? All it needs is total score. Now return, or like, percent is equal to self dot set percent. It takes two parameters, total score and self dot total subjects, and this returns the percentage. Okay, self dot percentage is equal to percent. Now after this, right, let us say set percent, and before that let me just print percentage, and I'm going to give 300. Percentage. What will be the percentage here? Six subjects and I have scored only 300. And if I calculate per subject, the 100 is the maximum marks. But 3 were given, which is this. All right, so here the static method, right? If you use self, the problem is that it will pass 3 parameters, because whenever I use self dot certain function, it passes self as the first parameter. Okay, that is the reason it is throwing error, right? Which means self student dot set percent takes 2 positional arguments, but we are giving 3. Whenever I use a self, it is going to. So what I'm going to do is I'm just going to call it with the, right? I'm just going to call it with okay, self dot total subject here also. Right, one moment. All right, all right, all right. I'm calling. Hold on, hold on. Set percent. Oh, it is compute percentage, right? Sorry. One moment, my bad. I have it's not the set percent. The static method name is compute percent, right? So sorry, my bad. So what is my percentage?
50, sir.
50, sir.
50, sir.
Right. So technically, so the way we calculate percentage is always by subject. We always say if we are calculating at 100 into 100 is what we do, right? So that is what we, oh, sorry. All right. What is this? Total by subject count into 100, right? What is the percentage calculator? What is the percentage formula?
Subject count by total
Subject
into
count by
100, sir.
total into hundreds.
Subject count by total, is it?
Total marks by gained marks by total marks into hundreds.
Ah, that is correct, right? So which is 300 by subject count into 100, right? If I'm, is that correct? No. Subject count. Yeah, sorry. This should go up. Is it correct? I don't know. Let us see. What is missing here? Subject count into 600 by. No, 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 no. Gained
Subject
marks.
count by total. Are they gained marks by totals?
So whatever it was there, that was correct actually then. Okay, this must be good enough for us for now. Right, so it basically says 50%. So if I just say What is my percentage if I have scored 350? Right, some 58.33. Right, so this is how you calculate a percent. Right, and well, so see, we know when. Now, do we have clarity on when to use a instance method, when to use a class method, and when to use a static method?
Yes, sir.
Yes,
Right,
sir.
so there are three types of methods, right? Instance method, static method, class method. Instance method will have no decorator, right? And the first parameter of the instance method would be self. Self is nothing but the object itself. Because self is an object, you can access all the object variables and also class variables. Clear?
Clear, sir.
Yes, sir.
Clear, sir.
Class method, it uses a decorator called @class method, and the first parameter of that class would be CLS, which is nothing but the class name or class reference, right? With the class method, you can have access to class variables only and cannot access instance variables. And whenever we want to update any of the class level variables, we have to use class method. Okay. Now static method uses a decorator called @static method. Right, since it is going to be a static, which means it will not have access to class variables or instance variables. It doesn't come up with any of the default parameters. It doesn't come up with any of the default parameters. Class variables, sorry, static method, it will not have access to class variables or instance variables. So the static method we will add into a class when you think that function belongs to this class but should not have access to class or the instance variables. Are we clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, this is a very important. We should have a clean understanding on the instance method and the purpose of using instance method and the purpose of using a instance method. Okay, the purpose of using a class method, when to use a class method, when to use the instance method. The purpose should be very, very clear. Okay, are we good?
Yes, sir.
Okay. All right. So the next things we will go and learn is we will learn few more special methods. We'll learn few more special methods. The one we have learned is underscore underscore unit. Right. Now we will learn few more special methods. Now special methods meaning always comes with what behavior? Certain special behavior, right? So all the special methods, because they are prefixed with underscore, double underscore, and suffixed with the double underscore, they can also be called as dunder methods. Dunder meaning double underscore, you can call them as dunder methods. You can call them as dunder methods. Clear?
Yes, sir.
Yes, sir. Clear, sir.
Okay. Now, whenever people might ask, what are special methods or what are dunder methods? So, or they can other name is magic methods. Magic methods, dunder methods, or special methods. right? Dunder methods, magic methods, or special methods. So all these three are one and the same, are one and the same. Are we good?
Yes, sir.
Okay. Now the one special method which we have already seen is underscore underscore init. What is the special property of this underscore underscore init? What is the special behavior of it underscore underscore init?
So it is a constructor.
It is a
Constructor.
constructor, and the special property is that we don't have to call it. It gets called whenever we create an object. It gets called whenever we create an object, right?
Yes.
Yeah. Now, in the same way, just like we have underscore underscore init, we also have few more functions. We also have few more functions which we will see. Right. When there is a constructor, there should also be a destructor. Yes. Right. If there is a constructor, there should also be a destructor. Now, what is a destructor? So before deleting this object, that function gets called. That function should get called. Now, the moment you say just like underscore underscore init, if you just say def underscore underscore, see, this will list all the dunder methods. This will list all the dunder methods, right? Now, if before deleting, so this is our destructor. Before deleting, right? If you want to do any of the cleanup job, you can use destructor method. You can, mostly we will not be using it, but it is good to know. Mostly we will not be using it, right? But it is good to know. But it is good to know, right? Sorry, it is not a delete. It must be del. Right. So we use this one function called del, right? We use one function called del. So far, whenever we want to delete, we use the function called del.
Yes, sir.
Now, whenever that del is called, this function will get triggered. This function will get triggered. Destructing the object. And I'm going to print whatever is that object that is being destructed. Okay. And before that, I also say. Now, this is also DICT is also special properties. It basically prints the object special properties. Okay. See, now when my program is exiting, what is it doing? Did you delete any of this object? But your del function has been called, right? How is that called? Now, there is one thing which we have to understand. There is a concept called garbage collection. There is a concept called garbage collection. So for a moment, we'll discuss about it before going further. Or in short, we call it as GC. Okay, you would have created objects, right? So for example, if I have so what happens in the memory? So whenever I say memory, what am I referring to? Whenever I say memory, what are we referring to? Which part of the memory are we referring to? Which kind of memory?
RAMs.
Right, we have discussed this long back in our previous class. Whenever we say memory, when it comes to programming, it is always RAM. Okay. Now let us say whenever I create object, there is a certain piece of memory that gets occupied, right? This object will get created in the memory, which means it takes up some space in the memory. Let us say it takes 1 MB. Example, right? Let us say this object takes 1 MB. I created another object. So your total, let us say example, okay, your total RAM memory is 10 MB. Your total RAM memory is 10 MB. Okay, now I created another object, which is D. Right, this also takes 1 MB. Okay, right, I created one more 1 MB. Right, this is X, this is D, and this is E. 3 objects I created. Now I executed this, my program execution is done. Complete. Yeah.
Yes, sir.
I rerun this file again. I rerun this file. Now, whenever I rerun this file, again it is creating objects. Okay. Again, there is some object called X, 1 MB. Again, there is object called D, 1 MB. Again, there is called object called E, 1 MB. So your total is how much? 10 MB. Already you have used how much in the memory? 6 MB. If I run this for one more time, so the total I ran 3 times. Now again there is a space created. So totally you have already used 9 MB. And next time when you try to run this program, you will run out of memory. You will get out of memory error, which means you ran out of memory. You don't have memory space to store anymore. You don't have memory space to store anymore, which means this try to run. So this it created one object, which is A, right? A, which is X. And the moment it created X, did it reach the memory limit of the 10 MB? 10 objects, 1 MB each. Did it reach the memory limit? Yes or no? Now it goes to the next line. It tries to create this object. And if it has to create this object, it has to create in the memory. Now, does the memory has any space?
No, sir.
No, sir.
Right, it had 10 MB and all the 10 MB is occupied. And hence you will hit out of memory error. You will hit out of memory error. Now, if in that case, if I have to recover myself, what I will have to do is this RAM is a temporary memory, yes?
Yes, sir.
Sir.
Meaning, as far as the computer is running, right, this RAM will be occupied. If you want to clean up the RAM, you just restart your system, you restart your laptop or a computer, then this RAM will delete everything and start freshly. Everything from the RAM will go and it will start freshly. Are we clear? Do we know that concept?
Yes, sir.
Right. Now, what was the problem here? See, every time I ran my program, I ended up creating new objects. But whenever this is a problem, yes, because if you don't clear, it keeps increasing the memory. Now, generally, you will have like 8 GB, 16 GB, 32 GB RAM. You don't see the problem. But if you keep running the program for like, several days, it will someday it will reach that memory limit and it will throw memory error. Okay, if you see, for example, all these servers, take Amazon, Google, Instagram, Facebook, YouTube, all of these should be running 24/7. The server should be running for 24/7 and millions and millions of users must be using that service, using that server. Yes, they're running 24/7 and there are millions of users who are accessing that system continuously. Yes.
Yes, sir.
Yes,
And
sir.
which means there is a program, there is a piece of code which is running on those servers. There is a piece of code which is running on those servers. Now, they will also be creating the piece of code with. Good night. Okay, which means the piece of code would be running on certain server, and the program would be creating several objects. The program would be creating several objects. But if they don't clear that memory, the objects for a period of time, because the millions of users are accessing simultaneously, right? Every second, every minute, then it keeps creating more and more objects. And at one point in time, it will run into out of memory error.
Yes, sir.
Yes, sir.
Right. Now, that is why all these high level programming languages, there are two low level programming languages and high level programming languages. So low level programming languages, if you create an object such as C, example is a C language. So what C language particularly, you have to be very, very smart in C language is that if you create an object, you should ensure that you delete that object also, so that that memory you have taken, you are freeing that memory. If you miss to do that as a developer, if you don't free that memory, that will stay in the memory forever. And eventually one day it gets out of memory and you have to restart it. There is no other option. Okay, in C, if you are creating an object, you have to ensure you delete the object. If you don't delete the object, that will stay in the memory forever. Clear?
Yes, sir.
But
Clear.
this is not in the case of high level programming languages. What are high level programming languages? Example, C++, Java, Python, and there are several other languages. Which means here you can create an object. Okay. Once the execution of that file or the function is done, once the execution of that file or that function is completed, we don't have to create. Your Python will take care of automatically clearing that memory, Now, any of these variables you have created now, in the first run, you have created this much, right? And once it hits the end of the file execution, right? Once it hits the end of the file execution, your Python will take care of deleting this memory also. Your Python will take care of deleting this also. The moment it runs and once the program is completed, your program execution should complete and stop, right? And right before stopping, it will ensure it will remove all the objects that it has created. It will remove all the objects that it has created. That way, in the first run, it created objects and also removed the objects. Any of the unused memory, unused as in the after the program, right? Any of that unused variables or objects that are there in the memory are basically called as garbage. Basically called as garbage because they're not used by anyone. They are just staying there because we did not clear, and hence it is called garbage, right? And your
Yes.
high level languages such as Java, Python, right? They will take care of clearing the garbage. They will take care of clearing the garbage as well, right? They will take care of clearing the garbage as well. That way, whenever, even if you create object and don't clear, your Python, the high level programming languages will take the responsibility of clearing the memory. That way, you will not hit the out of memory error. That way, you will not hit the out of memory error. Are we clear?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay, because the high level language, because your Python is taking care of the garbage collection, which means it is deleting that from the memory, which means it is deleting that object from the memory. Okay, are we clear?
Clear.
Yes,
Clear,
sir.
sir.
Right now, whenever your object is being destructed, whenever your object is being deleted from the memory, who gets triggered? Your del method. Your del method gets triggered. Your del method gets triggered. That is why once the program execution is completed, your program stops. And before stopping, just before stopping, your language should take care of deleting these objects. The objects, 3 objects that we created, S1, S2, and S3. Right, 3 objects we created. And just before stopping this program, your language should ensure that it removes that unused memory. Yes. It has to
Yes,
remove
sir.
these objects from the memory. And that is when it internally calls that delete function. It internally calls and tries to delete the object. And we have written this function, the special method, which is underscore underscore del underscore underscore. We don't trigger it, but whenever object B is being deleted, whenever object is being deleted, this function gets called by default. This function gets called by default. Are we clear?
Yes, sir.
Yes, sir.
Right? Your init gets called whenever you create an object. Your delete gets called whenever an object is being deleted. Whenever object is being deleted. So this is a explicit. This is implicit, right? So we don't have to do call this explicitly. The moment an object is being deleted, that guy gets called. Now what I'll do is, right? So even before what I'll do is I create an object and I delete an object. This is how we delete, right? This is how we delete a variable. This is how we delete a value from a array index and so on. Now what I'm going to do is I'm going to delete that object as well. I'm going to delete that object as well. Right? I created that object and we are deleting that object as well. Right? S3 is created and S3 is being deleted, which means, right? S3 I'm using somewhere here and I am going to comment this out. After deleting, you will not have that in the memory, right? S3 is gone. Here I'm deleting S3 and I'm trying to access S3 after the deletion, so it will not be there. So hence it throws an error. One moment. Right, if you see here, right? Okay, S3, where is that we are using? Okay, let me just comment this as well. If you see here, right? We created the S3 and we deleted the S3 right here. That is the reason you're seeing destructing the object. Right? Let me just print what is S3 also. We see S3 is the object that we created. And whenever I just said delete, I just said delete S3, it internally called my del method. We internally called the special del method. And are these two same?
Yes, sir.
Which means you have two special methods now. One gets called whenever an object is being created, whenever an object is being created, and another function gets called whenever object is being deleted, whenever object is being deleted. So if you want to to perform certain action when an object is being deleted, you can implement underscore underscore del and use that special method to perform any action that you want to do before deleting that object. OK. And if you use a constructor, right, and that gets called whenever an object is being created. And if you use that constructor, if you want to construct the object with the special variables at the time of creating object. Are we clear?
Clear,
Yes,
sir.
Yeah. All right. Now let me just try doing something here. Now I want to just say, we have used, if I want to convert an integer to string, what function did I use? Str function.
Yes,
yes,
sir.
sir.
Now I'm going to say str of s1. I want to print, right? You're seeing this. When I did str of 1, it is printing this much. Oh, sorry, this is not right. This is what it is getting printed. What I'm going to do here, right? So I'm just going to comment this del because this is going to cause unwanted confusion. Sorry. I'm going to comment this function. Okay, let me just say. Right, when I said str of s1, it is still printing the object, but it is not printing what is there in the object. My intention, if I say str, so I should get the string representation of this object, the string representation of this object, but it is not doing that, as it is rather giving me some object reference. I don't want that, right? So that is when I want to implement this str functionality into my class. I want to implement this str functionality into my class. So what I'm going to do is str underscore underscore str. Right now, whenever I call str function, this function gets triggered on that object. Okay, now what I'm going to do here is string representation is equal to, I'm going to use f of self dot full name. I'm going to call that function, comma, self dot full name class. What do we have? All right, so now I'm going to return this. I'm going to return this much. Now, whenever I call str function, now this function is going to get called, and this is what is going to get printed. Are we clear?
Yes, sir.
Whenever I call str, right, and that function will get called. Whenever I call str, that function will get called. Right, str of s1, and I'm going to say s2, and s3 is anyways deleted. This will not delete this, right? Whenever I call str, this function gets called because I'm overriding the str functionality using this special method called str. Now you see why they are called magic methods or a special methods or a dunder. Dunder methods is a general name. The reason is, like, why it is called a special method or a magic method is basically it has got some certain special behavior, where you can use that behavior, to your convenience, okay, and make some sensible output of that. Are we clear?
Yes, sir.
Yes, sir.
Right? So if you want to have a string representation of of any class, you have to override underscore underscore str underscore underscore special method. And the first parameter, it is always going to be self. All this dunder methods, first parameter will be self, and you can use that self to access all the instance variables and print any of the string representation that you want to for any given object. Clear?
Yes, sir.
Yes.
Okay.
Yes, sir.
Now homework. I will give, right, underscore underscore few more special methods, underscore underscore add, underscore 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 sub, underscore underscore. You can also add behavior, like, if I add a plus or minus between two objects, what should I do? Right? Underscore underscore repr, right? What special, underscore underscore new, underscore underscore, right? I want you to implement, understand and implement values for this. And if before sending me, you have to write complete comment on what each one does. Basically write a comment what this is doing, what this is doing, what this is doing, and what this is doing. You have to write based on your understanding. You have to write a comment and then send those pictures to me. Clear?
Okay, sir.
Okay.
Okay, sir.
Right. Okay, then I'll see you guys tomorrow. Please do without a mess. Do this. Okay.
Okay, sir.
We
All
will
right
try,
then.
sir.